This session is about designing scalable solutions, especially multi-tenancy architectures using PostgreSQL as an open source engine. I mean, in any multi-tenancy solutions, tenancy isolation is a key thing, right? And in addition to the tenancy isolation, what you need is the scalability and high availability are very, very important factors. So today we are going to learn about various best practices using PostgreSQL engine. My name is Krishna Sarabu. I'm a senior database engineer at AWS. I've been with the PostgreSQL for about 8 years now, but prior to that, I worked with Oracle Database Engine for about 20 plus years. And I've done some contributions to patterning. If you look at multi-synchronous support, so that's from me for the patterning. All right, the agenda for today is, I'm going to skip the first one, what is SaaS and the marketing part, but we're going to focus on the single tenancy versus multi-tenancy and the advantages versus disadvantages. And then we're going to look into various deployment models on multi-tenancy systems. And the most important thing is the decision metrics, which model to choose and when to choose. And we're going to look at multi-tenancy design recommendations, and we're going to look into PostgreSQL features for multi-tenancy, and finally, we're going to look into the sharding solution to scale out horizontally for your tenancy models. So the first one is the single tenancy versus multi-tenancy. So here what we are looking at is the single tenancy model. I mean, typically, when you are using single tenancy model, for every tenant, you're going to use a dedicated infrastructure. So maybe it's an application layer, application stack, or the database stack all the way down, right? So typically users get authenticated through any authentication and authorization tools like Cognito, and they go into the application stack, which is completely isolated, could be running on Kubernetes or any other containerized apps, and then all the way they go into the database through RBAC authentication. Sorry, not RBAC, through the database authentication, either using, if you're on RDS, you can use IAM authentication. PostgreSQL does support MD5, and as well as if you're on RDS or Aurora, it does support IAM authentication, cover authentication. And what you see is, in this case, the pros are, you get the comprehensive element, in the sense the tenancy, the data, and the application stack are completely isolated, so you don't have to worry about it. And especially if you have a tenant who's bringing his own CMK, for encrypting the data in transit or at rest, so you have that choice when you have this single tenancy model. Another one is partitioned environments. So if there is a noisy tenant, it's not going to impact the performance of other tenants. So it's completely isolated and partitioned into its own infrastructure, right? And so the third one is no cross-tenant impacts. We don't have to worry about, and especially you can do tenant-specific tuning. So if you want to add indexes, for example, for that particular tenant, or if you want to increase any tuned parameters like shared buffers, so and so forth, so you could do that. And the availability, if you are performing major version upgrades, minor version upgrades, so the blast radius is limited to the one single tenant. It's not going to impact other tenants. So the considerations, the cost, because of the sprawl of databases, and the application database, the infrastructure at the application stack and the database stack, so that's going to put enormous cost in front of you. Agility is compromised naturally because you need to provision the infrastructure. So, and the third one is, of course, the management complexity. So you have sprawl of databases and application stack, which you need to monitor and manage. And of course, the deployment challenges, and when you are aggregating the analytics or the metering, that's another challenge you're looking at with a single tenancy. So why do SaaS vendors, particularly goes to multi-tenancy model, right? So particularly with the growth. So what you're looking at is, why do they prefer multi-tenancy model? Underneath, they share the infrastructure for multiple tenants. That is going to give them the best cost optimization possible and the business value. And of course, using that, they can quickly grow. And the agility is, of course, another one. So they don't have to provision any new hardware. So they can utilize the existing hardware, but by using shared infrastructure. So that's 4 factors they typically consider. So why PostgreSQL engine? So when you're looking at the PostgreSQL, the first one is it's an open source engine, and it provides advanced security features. Now, something like you can use role level security, for example, which can give you the tenancy isolation, the highest level of security that's possible within the database engine. And you can use RBAC, the roles, and the minimum privileges within the database. So to limit what users can access, what they cannot, right? And you can use PgCrypto extensions like. So the PgCrypto can help you encrypt secured columns, something like social security or any other key columns. And the second one is the scalability and availability. Yep, you can, with the PostgreSQL streaming replication, you can horizontally scale your writer node into multiple read replicas, and you can scale read-intensive workloads across your read replicas. Of course, if you are using open source solutions, you can use HA proxy, which can load balance across your queries, across reader nodes, and extensive ecosystem of tools and extensions. For example, if you want to provide high availability, you can use tools like patterning, which can utilize distributed consensus system and give you the high availability for your database. And tools like, if you are monitoring, you can use tools like PgBudget, for example. So there are wide, and you can use PgAdmin, for example, for the management. And lots of extensions by the community. Say, for example, PgLogical, if you are looking at for the logical application. And for example, if you have geospatial data, you can use PostgreSQL, right? And if you are, see, just now we discussed about execution plans. If you want to provide plan directives, for example, to the Postgres database engine, you can use something like PgInPlan, right? So there are large number of extensions, PostgreSQL ecosystem provides, and the more importantly, strong community support, right? And very active development, which Vivek just talked about, how often PostgreSQL community releases minor versions and major versions. All right, let's look into multi-tenancy model. So the first one, we already looked into single tenancy model. That's also, we also call that as siloed model, right? So when you have the dedicated infrastructure from the application stack to the database layer, right? So in a multi-tenancy model, so first one we are going to look at it in a pool model. In a pool model, typically you define a table, right? And you onboard all the tenants into same schema, same database, and all these tenants use same set of tables. And these particular tables, use tenancy ID, for example. So that provides some kind of isolation. So when application pulling the data, they can pull the data. So typically, right, when user authenticates through application, if you're using something like Cognito, you can set underneath once he's authorized successfully, they can set a context to that user, right? And using that context, that you can translate to what tenancy in the database layer this particular tenant is using, and then you can apply the where predicates within the application layer when it is pulling the data or inserting the data, right? Or updating the data. So in this particular example, what you're seeing is on the left-hand side, the tenancy ID, like tenant 1, 2, and 3, are sharing common set of database objects. And the advantages are agility, naturally, right? The onboarding customers is pretty easy. You don't have to provision new schemas or new database instances. You just onboard the tenant, and they can start using your database. And the cost optimization, because it is shared underneath, the infrastructure is shared underneath, so the cost is distributed among all the tenants who are onboarded to particular database instance, right? And third one is the centralized management for availability DR. So so the management is simplified deployment and management because of that. And finally, the metering aggregation. Now that all the tenants are sharing the same infrastructure, so you have aggregated metering. But there are some constraints too. So the considerations you have to look at is, if there is a tenant who probably not using much of resources today, but tomorrow as he grows, he may start using more and more resources and may become noisy on that particular database. So the car and start impacting other tenants who are sharing the same infrastructure. So that's going to be a major concern. And the second one is the compliancy challenges. Often you come across tenants who wants to bring their own encryption key. So typically, right, they don't want to use the shared encryption key in the table. So in that case, the compliancy challenges comes into play. And there are sometimes strict requirements. They don't want to share their data with other tenants. And the third one is the data isolation. So even though your application is using web predicates, there is always a challenge because these tenants are accessing same database objects. It is a possibility the tenant can start see the data from other tenant. So that's a huge risk.
I would say one pro on the pro side here is that the tenants are really different in size.
Yes.
It's easier to not have to solve the biggest problem.
Absolutely. You're right. So, I mean, that's one of the slides I'm going to talk about. Yes. So basically, when you're onboarding the tenants, right-sizing compute is always a challenge. So having a shared infrastructure, we don't have to worry about that. You're right, absolutely. So the fourth one in constraints is the data security and the breach. And finally, the restore. The restore is nothing but if one tenant screws up the data, and if you want to perform restore, you cannot do partial restore. It has to be point-in-time restore is going to hit all the tenants who are sharing that database. And let's look at the next model, which is called bridge model. So in bridge model, typically you isolate the tenants. In PostgreSQL, you can either isolate by schema or by database. Right? For every tenant, you can create a database. For every tenant, you can create a schema. So in this particular one, the advantage again, the agility. So because the infrastructure is already provided, you just need to create the schema, related database objects, and you can onboard the tenant. And naturally, all these tenants, even though they are isolated by schemas or databases, they are underneath they are sharing the same infrastructure for the database. So that brings the cost optimization into play. And central management by providing high availability DR. If you are using managed databases like RDS and Aurora, so that automatically takes care of for you. And if you are self-managing it, naturally you could do it through streaming replication or tools like patterning. Right? And comparing with the previous one, bridge model provides better tenancy isolation because naturally you can limit the access to each tenant, by roles or who can access the particular schema. So that way, one tenant cannot access objects from different schema. Limited by you can limit that by the rules. Constraints cross-tenant impact the same issue we have seen in earlier model. If there is a noisy tenant, it starts impacting other tenants sharing the same infrastructure. And security and compliance is still a challenge in this model as well, especially if a tenant wants to bring his own encryption key. And difficult to allocate cost per tenant. So the same thing applies in the previous model as well. Because we are sharing the infrastructure, so when you are looking at the cost allocation, actually this is somewhat solvable, I would say, because it's isolated by the schemas and the users. But in the earlier model, the pool model, it's because they are sharing the same table, it's really difficult in that case. And again, making changes at tenancy level is a little bit of challenge in the sense, not the schema objects, the instance level changes. You want to increase buffer cache, for example. You want to increase parallel slaves, for example. So that's going to give, that's going to be at the instance level, not the individual tenant level. And finally, the restore data, same rule applies like last time. But at least it's feasible that you can do point-in-time restore in other database and just PG down, PG restore the particular schema because it is isolated by the schema of the database. And the mixed hybrid mode. So in hybrid mode, so this is what I have seen is majority of the customers using the hybrid mode. So where possible, basically you have a premium tenant, for example. So who wants to pay additional premium for bringing additional layer of security where they wanted to isolate their data into the separate infrastructure, which is not being shared with any other tenant. And similarly, where they wanted to bring their own encryption key, for example, right? So you can move them into siloed model, where the tenant N and M, for example, in this case, and where other tenants, for example, who are not premium but wants to share the infrastructure, you can move them into a bridge model, like by isolated by schema or database. But typically, I would recommend by schema. And here is the decision matrix. This is very, very important. So when you're gonna finalize, okay, which model should I go with? So this is the decision matrix you should look into. So I'm gonna start with the first one. For example, when it comes to provisioning and management considerations, right? Especially from the point of agility, in silo it's significant because for every tenant who is onboarding, you need to, for application stack to the database stack, you need to provision the infrastructure. So that is going to be a significant. But the rebalance effort is very minimal because in siloed model, one tenant is not going to impact other tenant. So the rebalance effort is near zero, actually zero, I would say, right? When it comes to bridge, it's going to be moderate, even though that brings cost efficiency into the picture, cost optimization into the picture, but the rebalance effort is going to be a little bit of moderate. And in pool model, it is going to be significant because all the tenants are sharing the tables, and exporting requires exporting subset of data. So that's going to be a significant, but agility is pretty minimal. And from high availability and DR point of view, especially when you're performing major version upgrades, or in siloed model, it's going to be very, very minimal because when you're performing major version or minor version upgrade, the impact is going to be only to that particular tenant, right? And even though, and similarly, tenant-specific backups and point-in-time recovery, the blast radius is going to be minimal to the tenant in siloed model. When it comes to bridge, it's going to be moderate. And pool is going to be, I would say, high because I don't know why I put the minimal. It doesn't make any sense. The downtime is going to impact everyone basically, right? All the tenants are onboarded. So, the next one is the application dependency. So one is the uniform schema name. All right. Typically, what you want is having a uniform schema and object names. In siloed, naturally, it's going to be minimal. And in bridge also, because it's isolated by schema names, namespaces, or database namespaces. So it is going to be minimal. But when it comes to pool, it's going to be one schema. So naturally, I don't know why I put significant. It should be minimal too. It's going to be one schema, one table, shared by all the tenants, right? But you cannot do per tenant customization. So naturally, that's going to be significant in pool model. And security consideration, again, siloed is minimal, bridge is again moderate for data isolation, and tenant-specific storage encryption key, it is going to be significant in a bridge model because it's a shared infrastructure, right? And same thing with the pool, shared infrastructure is going to be significant. Cost efficiency, naturally the pool brings you the best cost efficiency possible, and bridge is going to be a little bit of moderate, I would say. Siloed is going to be a significant cost impact. And finally, the monitoring in siloed is going to be minimal, and the bridge and pool is going to be moderate and significant, especially if you want to do tenant-specific monitoring. And more importantly, the service limits, right? When you are deploying multi-tenancy models, you have to keep in mind. I want to talk about that. Not only the service limit, the Postgres limits as well, right? There are some corner cases I have come across with many customers. So in this slide, I'm going to talk about just the service limits. See, for example, if you have an account, how many databases I can deploy, how many proxies I can deploy, how many EC2 instances I can deploy, how many subnet groups, right? So they all come into play. So in siloed, it's going to be significant because every tenant requires a dedicated infra, right? And bridge and pool is going to be moderate. because it's shared infrastructure. All right, now let's talk about the challenges, right? So the first one is, as I started off, isolation, right? The data isolation is very, very challenging when it comes to multi-tenancy model. So ensuring that each tenant's data is securely isolated from other tenants, right? So if you are using a pool model, how I can do that? Something like row-level security. I have an example in the next slide. I'm going to show you that, right? And of course, bridge and siloed model, you don't have to worry about it. They're already isolated by schema or by database engine itself. And the next one is the scalable.
Also, pull a lot good software, right? You do it in the software side.
Yes, absolutely. You can definitely, yeah. If you're within the application, we can enforce those predicates and we can enable that isolation. Yeah. And the next one is scalability. So ability, very important in multi-tenancy model is, the tenancy bin packing, right? So let's say I have provisioned a database engine, so which is like, 32 core or 64 cores, right? Onto 64 core compute, for example. And then, and you are continuously monitoring those tenants, and there comes to a point where you need to vertically scale the compute or horizontally scale out the compute. So how you're going to look at it, right? That requires a consistent performance, giving consistent performance to all the tenants, and more importantly, you need to consistently monitor all the tenants and see when you can scale up and scale out. And tenant-specific customizations, particularly if there is a premium tenant and he requires, so let's say a tenant wants to have additional replicas to scale out his workload. So how I can do that? So those are all the challenges you need to consider. And finally, the monitoring and billing, very, very important. If you're using pool model or bridge model, because it's a shared infrastructure, how could you implement that, right? Tracking the resource, it's like a show back, right? You need to track the usage and you need to show back the charges to the customer.
May I ask one question, Krishna?
Yes, please.
So I met with a database user and they had a question that they have a multi-tenant database on PostgreSQL. Assume that it's managed service, say that RDS. They don't have access to the host. Now they want to create a costing mechanism for the multiple tenants. Like you mentioned, the resources, we cannot do it, but is there any best practices to measure CPU, IO, memory? The storage, we can find out what storage is consumed by a particular table and relation. Any hint, like we have PgStat.io now available, will that be helpful to find the IO particular table or any idea?
Yeah, definitely. A good question, right? If you're using pool or bridge model, siloed, not siloed, pool or bridge model, and if you want to show up those charges, so one thing is if you're using RDS or Aurora, you can utilize something like PI, Performance Insights, for example, right? PI, all it does is, there are various tools available in the open source, right? I work with PgStat sampling, for example, right? And POWA, I think. I'm not sure if you have heard about it. It's like a performance workload analyzer, POWA. This is something like Oracle AWR and Oracle Ash. It works that way in open source world. But what I want to say is, you can rely on any tooling that can help you, that can sample the database for every second, and that can show back the CPU usage, IOPS usage, right, and any other rate events, right? And depending on the database load, you can break down the database. So let's say if you're isolating your tenancies by schema, that means naturally there are different users. Or if you're isolating by the database, so you can then take out the total database load, and then you can show back the distribution across how much percentage each tenant used in that month or in that week.
One more question came up that when we isolate based on schema versus when we isolate based on databases, is there any difference on the isolation, or what do you think?
Yeah, there is a huge difference when it comes to Postgres. I think this is like 2 weeks back, I was working with a customer, and the tenancy he was using was pool model. In the sense, it's a single table, not partitioned, and all the tenants' data was in that single table. So, and to make the things worse, he was using toast column in the table. So in PostgreSQL, whenever you use a toast column, right? So every toast gets a OID, object identifier, every row that's toasted. And that's limited by 4 billion, if you know. So what happens is insert goes through just fine until you touch the point of 4 billion, and then the performance falls through. So when when I was working with a customer, I mean, the insert was taking like about seconds to a minute. It was in that worst case range. So we have to keep in mind when you are designing these models, right? Especially how much data each tenant is going to have, and am I going to hit any limits in PostgreSQL, right? From transaction ID wraparound to OID exhaustion, right? Anything I'm going to touch, that's very, very important. Did I answer the question, or I went into a different route?
Yes, thank you. Good.
Have you found, I assume you're using row-level security, have you found any leakage? Started investigating some documentation.
I found a bug actually with the performance. I found a bug, not a bug, limitation in PostgreSQL using row-level security and partitioning. So I had to work around in this tenancy model. I can show the example. I just need to work around in the sense leakage basically. That was like a data leakage only for multi-tenancy. So what happened was in this particular situation, the customer was onboarding from Oracle to Postgres, and he was using row-level security in Oracle, and he was transferring to PostgreSQL using row-level security. And what happened was he came back and he said, you know what? One tenancy is returning other tenancy data, even though I'm setting the tenancy ID at my session level, it's returning other tenancy data. So it took me a while to figure it out why it's happening, but we worked around and we provided a solution. So I can show you the example. So there was a leakage, but other than that, haven't found any.
That was just a bug.
So I'm curious to understand your use case where you have seen the leakage.
Oh, no, I read about it. We're investigating row-level security, so I started doing a little homework. And I read about it.
There was some known issues with it.
With it.
Yeah, that haven't fixed. Yeah. That's a big deal. If you found something that's
Yes,
got
got it.
But what you found was correct. It wasn't something in the model.
Yes, it was something we came across and we had to work around with that.
So was it a bug or was it?
It was not a bug, it's a limitation. Actually, what happens is when you set the session context, you were setting a session context in a procedure, in a function, and the function is a deterministic function, defined as. So what happens is, second time when you call, it's not resetting
Yeah,
the
it's
value.
immutable.
Exactly. Cache value. And on top of it, he was using connection pooling on JDBC side. So these connections are being shared across tenants, right, within the application. And on the database layer, because this session is already pre-existing session, but being shared across tenants.
Yeah, discarded claims.
Exactly.
That's not a bug in RLM.
It's not a bug. It's how the PostgreSQL works. We just had to, whenever application was releasing the connection, I just had to say reset all.
It's a powerful idea.
Absolutely. And another one I wanted to show you if we have time is the performance problem we ran into with the partitioning layer using RLS. So the next one is going to be, there you go. The next one is redistributing the tenants, right? So we just talked about it. So let's say you you carefully looked at your tenants and you onboarded the tenants into, let's say, a 64 core compute or 128 core compute, right? And the tenant is going to evolve over time. As the tenant is going to evolve, his requirements are going to change, right? And the key challenge comes to you is how I can redistribute these tenants. For example, the tenant, as he goes, he says he comes back, I need to have additional RAID replicas, for example. Or he wants to come back and say, you know what, security requirements change, I want to bring my own security encryption key. So, or he becomes a noisy and you want to isolate that tenant. Reason, whatever it may be, how you're going to redistribute these tenants to balance the workload across the clusters, right? That's another second challenge. And the third one is, backing up restore is time consuming as your tenants increase in one single instance. Azure database size is going to go up. Costly, I don't know why I wrote costly. I'm going to skip that.
So how,
Sorry, let me go back.
how do you bring encryption keys when you're using RLS? Can you do
It's
that?
not good. It's not good.
Yeah, I mean, RLS is gonna provide an abstraction on the query engine layer to inject a predicate to your query, right? You know, when you run a query, it's gonna look at your session context, you know, based on how the policy is defined, and it's gonna add that additional predicate. Encryption. Yes. So the thing is, naturally, every relation you're going to create is going to have the organic tenancy ID within the relation, and which you're going to use as a predicate from the policy, right? The encryption key, on the other hand, is going to be like when you want to do encrypt your data at rest, or you want to encrypt data while it is in transit. You know, that's an additional layer of security in addition to. So, in a nutshell, RLS is going to provide you the isolation. Encryption is going to secure your data when it is rested.
And check, Krishna, I think you have only 5 minutes more left here.
Okay. So, oh, that's an interesting question. Actually,
It's been there for a while.
It's
How do
here.
you guys gotten better?
it's been there forever, I think, but yeah, I need to go back and check.
No worry, no worry.
So, Krishna, this was a 20 minutes talk, so it would be great if you can wrap up a bit.
Yeah, absolutely. I would say 3 more slides and I'm done. Right? Actually, I want to talk about more, but I'll stop there. All right, you know, did I skip the slide? No, right? Yeah. So the next one is the cost versus management. You know, we just talked about it, right? So when you're onboarding the tenants, you know, right sizing the compute is always a challenge, right? So if you oversize, if you undersize, it's going to be insufficient capacity, and your tenants are going to suffer. If you oversize the compute, I mean, it's going to be additional cost, and it's going to be underutilized and expensive. So what's needed in this case is, you know, you need to continuously monitor and allocate the right sized compute, you know, depending on the needs of scale up, scale down, or scale out, right? So the sizing challenge, you know, typically we just talked about it. I mean, you will have mixed tenants, you know, one tenant is large, medium, small, and how do you accommodate, you know, different size tenants, and especially how do you isolate these noisy tenants, right? And how do you prevent the over provisioning? And more importantly, how do you optimize based on the actual consumption of your tenants, right? So, and how do you meet and support the needed SLAs for all your tenants, right? So that brings down to how do you what are the factors you should look into when you impact the tenant, right? So the typical factors I would always look into on the right hand side. What you need is, you know, per tenant utilization, right? How much he's going to use the CPU, and how often how many transactions he's going to run, right? And how many IOPS he's going to use, and of course how much data he's going to pull, the network throughput. So when you're looking at the compute, the CPU, IO, the network, right? So that comes into the play. But when it comes to PostgreSQL, the connections are very, very important. See, if you're coming from Oracle background, you have SGA, PGA. PGA is shared by multiple sessions, but in PostgreSQL, every connection has its own rel cache. That means any relation, the connection is going to access, the cache of the relation is going to be stored in the process memory. So that's going to consume additional memory. So as a reason, any PostgreSQL expert you talk to, when you say 5,000 connections, you say what, you know? So they always advise you to use connection pool. So something like, you know, PG Bouncer, actually PgCat is another great tool, by the way. And then if you are using managed solutions like RDS Proxy in AWS. And of course, the number of relations are very, very important. Remember, if I create millions of relations, millions of indexes, it's going to bloat my catalog. That's going to impact my performance. It's very, very important. The size, growth rate, and the temporary space usage. You know, on that note, I have seen a customer dropping temporary tables, creating drop-in for every transaction. That bloated PG class, PG attribute. As a result, my performance completely regressed. process memory usage, I just talked about it. In addition to workload maintenance, rel cache, the number of relations each process access. And finally, the encryption. So all this comes into play per tenant, and you aggregate that into the database instance level, right? So if I'm going to, as a standard in my enterprise, if I'm going to use 64 core, for example, so using these metrics, you can compute. So this many cores I have, this much memory and this much network throughput. So how many tenants I can onboard, right? Based on all these dimensions. And the storage type, I want to consider comes into play. If you're on RDS, so you could use GP3, GP2, IO1, or IO2 Block Express. Aurora, only local EBS storage, but Aurora uses a detached, it's a decoupled compute and storage model. And the number of connections, objects, they are very, very important for database instance metrics. So should I stop here, or do I have 2 more minutes?
I would suggest that let's stop here because keeping time in the mind.
Okay.
And it was 20 minutes allocated, so we can have the last one and that was the last.
Yeah. I just want to browse through quickly. So 3 more slides. So performance considerations, we just talked about connection pooling, right? And only I'll highlight the important ones. Sub-transactions. Anyone heard about sub-transactions in PostgreSQL? It's very, very important. What happens is most of the applications use ORM tools. What I have seen is when they migrate from Oracle especially, they don't change any settings. They just come on board on PostgreSQL. And what it does is it uses something called, if you're using JDBC, there is something called autosave, right? So what it does is for every statement it executes, it creates a sub-transaction. It's like a save point in PostgreSQL. So it's not good at all. So every sub-transaction, it accelerates your transaction ID generation, and that is going to quickly reach your vacuum freeze, which is 200 million, and naturally your vacuum starts freezing all the relations, and you would see, and not only that, right? Not only that, if I have high concurrency in my database application, and what I have seen is sessions using more than 64 sub-transactions in one single transaction, that means it's doing more than 64 save points, or using exceptions, for example, in PgSQL, right? Every exception creates a sub-transaction, by the way. So what it does is, the SLRU for sub-transactions is only 64, the array that's used by the process. So anything beyond 64 is going to spill to the disk, and that's, you start seeing the weightiness relates to sub-transactions SLRU. So that's very, very important. You need to keep that in mind. And TCP keep alive, already we talked about it. And one important, in addition to TCP keep alive, there is something called client connection check interval. I'm not sure how many of you familiar with this parameter. It's introduced in 14. What happens is in PostgreSQL, if there is a runaway session, means, let's say there is an application session that started a huge SQL that runs for hours and days, and somebody terminates the application, for example. So that session in the database will continue to run, and it's not going to realize the TCP, though you said TCP keep alive, it's not going to realize until it will try to send the first record. So when it tries to fetch the first record and send it back to the client, then it realizes engine, oh, there is no client, and then it closes the, it cleans up the process. So that means the process is going to run forever until it completes. And until that time, your vacuum cannot do anything because of the read consistency. All the dead tuples will be kept by the engine because of this runaway session. So it's very, very important you set up TCP keep alive, and more importantly, client connection check interval, which is, by the way, default set to 0. And the remaining, partitioning. I want to talk about the one last thing: partitioning and sub-partitioning. PostgreSQL, though it supports declarative partitioning, when you create the number of partitions, very, very important to keep in mind, the engine is not good for supporting more than 1,000 or 2,000 partitions. You start seeing LW lock on transaction lock manager. Yeah, that's about it. I'm going to stop now. Out of time. Sorry about that. I'll share the deck. And
that was really good talk.
Yeah, thank you. And thank you all.
Hey, couple of things. Sorry, I missed this. One thing is that the site is like almost a commercial offering for the full model. Right? I am with the full model, and it works really well. It's probably the most difficult to do, but maybe the best if you can get it working right. Right? Yes. As long as you
Though it is offered enterprise, you can do
Community, yeah.
community. Yeah, you can do open source for self-managed. I mean, yeah. I mean, there is science, and if you want to do an application layer, I didn't have time to talk about something called sharding sphere. I'm not sure if you have heard about it, right? And
I did myself, but my question would like to answer, it's an important one. So multi-tenant models, and you have these, obviously, Postgres, but the snowflakes and the different things. So what do you see from customers as far as, are they still adopting multi-tenant model, or is it obsolete in the face of, high scalability?
I mean, they are. I've seen lots of customers onboarding to that tool. Usually, typically, they implement the tenancy isolation at the application layer, though they use underlying shared infrastructure for the database or SQL or NoSQL.
Krishna, would you like to share like how people can connect to you for follow-up question? Maybe LinkedIn would be the good one.
Yes, absolutely.
Awesome.